Welcome to qnawire.
So now we'll work on problem 38 from chapter 20. In this problem, we're asked to use the data in Appendix E to calculate the standard EMF for each of the following reactions. So we simply first need to identify the oxidation and reduction half reactions, and then we can find the values that we need from the appendix. So for the first reaction, we're given hydrogen plus fluorine breaking up into hydrogen and fluorine ions. So for each reaction, we'll write it as a reduction. So we have 2 H plus 2 electrons will make H2. We're switching it because we want to write it as a reduction. This one is correct in the correct format. So we look in the appendix for the reduction values for these. And the hydrogen we know is 0 because that's what we set to be 0. And the reduction of the fluorine is plus 2.87. So for the cell, it will be cathode minus anode. And since this one here is where the reduction is taking place, it's the cathode. So we have 2.87 plus minus 0. Doesn't matter. And we get 2.87 volts as our potential for this reaction. So we can move to part B, where we have a copper and calcium reaction. So first, we have copper 2, which is the reduction that's occurring in this reaction. We have 2 electrons and produces copper, and then we can flip the calcium, which is being oxidized, but we flip it to show the reduction reaction that we want to look for in Appendix E, and we get calcium neutral. And the value of the reduction for copper is 0.34 volts. And for calcium is negative 2.87 volts. 2.87. So the potential for the cell will be equal to the reduction, the cathode, 0.34, minus 2.87 for the oxidation, and we get a value of 3.21 volts. In part C, we have a reaction involving iron 2, iron 3, and iron neutral. And so it may not be clear here exactly how we're going to break up these problems. If we look at the reactions, the half reactions that are given in Appendix E, it might be helpful. So first we look at, we see that 3 iron 2s are turning into iron neutral and 2 iron 3s. So first, one reduction reaction that's taking place here is iron 2 plus 2 electrons is producing iron neutral. That's the reduction that's taking place. And then iron 3 plus will react to give iron, so we want to write it as a reduction, so we want iron 2 to go first. Let's go ahead and write it as reduction because that's how it's written in the book. So we have iron 3, iron 2, iron 3 plus 1 electron makes iron 2. And this value here is negative 0.44 volts. And the reduction of iron 3 to iron 2 is, if we check Appendix E, positive 0.77. So the energy of the cell, the potential of the cell, is going to be equal to the reduction minus the oxidation, or the cathode minus the anode. So we have negative 0.44 volts minus 0.771 volts, which is equal to negative 1.211 volts. And for part D, the last reaction, we're given a chlorate and bromine reaction. So we can go ahead and divide these two reactions here. First, we have 2 chlorate reacting with the protons, 12 protons and 10 electrons, to produce chlorine, Cl2, and 6 waters. And then the other reaction that we have, the half reaction, is 5 of this Br2 plus 2 electrons, producing 2 bromine minus. So the energy of reduction, the potential of the reduction, is 1.47, and for this bromine reaction is for 1.07. So the potential of the cell is equal to 1.47 minus 1.07, and that's equal to 0.40